Researchers studying human migration patterns have confirmed that ancient humans successfully colonized literally every continent on Earth except Antarctica, using nothing but their own 2 feet and some genuinely audacious boats. Reaching isolated Pacific islands separated from the nearest landmass by thousands of miles of open ocean, all without a single compass, a single map, or a single written record explaining how any of it was actually accomplished. No GPS, no combustion engine, no modern understanding of currents, weather systems, or celestial navigation written down in any textbook. Just raw, accumulated human ingenuity applied consistently, generation after generation, until our species had quietly spread itself across nearly the entire habitable surface of the planet. Let's start with the most basic, almost embarrassingly simple driver behind all of this movement: food. Ancient humans, particularly hunter-gatherer populations, weren't migrating for the thrill of discovering new horizons. They were following resources, tracking migrating animal herds, following seasonal plant availability, and moving away from areas where local food sources had become depleted. This created a kind of slow generational drift. A group might move only a relatively modest distance within their own lifetime, but compounded across hundreds or thousands of generations. That modest repeated movement adds up to genuinely staggering total distances covered across the full span of human history. This concept matters enormously for understanding the full picture, because ancient long-distance travel almost never looked like one person or one small group deciding to walk from Africa to Australia in a single heroic journey. It looked considerably more like a slow, multi-generational ripple, a population gradually expanding into new territory at the edges of where they already lived, with each subsequent generation pushing the boundary just a little bit further outward in pursuit of better hunting grounds, more reliable water sources, or simply more space as local populations grew and existing territory became more crowded. Let's bring up something genuinely fascinating regarding the actual physical capability ancient humans possessed for this kind of sustained movement, because we touched on persistence hunting in a previous video, and that exact same underlying physiology applies directly here too. The human body, with its remarkably efficient sweating system, upright bipedal walking gait, and impressive capacity for sustained, moderate-intensity physical exertion over extended periods, was genuinely well-suited for covering large distances on foot. Comparative research on contemporary hunter-gatherer and traditional walking-based societies has found that regularly covering 10 to 20 miles in a single day on foot carrying supplies wasn't considered some kind of extraordinary athletic feat. It represented a fairly normal, sustainable, daily travel capacity for populations whose bodies and lifestyles were consistently conditioned for exactly this kind of activity from childhood onward. Now let's bring in something that probably deserves more credit than it usually gets in popular conversations about ancient migration: environmental knowledge and tracking skill. Successfully traveling across unfamiliar terrain without getting lost, without running out of water, and without walking directly into genuinely dangerous conditions required an enormous accumulated body of practical environmental knowledge, reading landscape features, understanding how to locate water sources by observing vegetation patterns or animal behavior, recognizing seasonal weather patterns specific to a given region. This kind of knowledge wasn't something one person figured out alone during a single journey. It represented generations of accumulated observation, passed down through oral tradition, that allowed ancient travelers to navigate genuinely unfamiliar territory with considerably more confidence and safety than a modern person, dropped into the same environment with zero preparation, would likely manage. Let's bring up something genuinely important regarding the actual route ancient humans took out of Africa specifically, because this connects directly to one of the most significant migration events in our entire species history. Genetic and archaeological evidence suggests early Homo sapiens populations migrated out of Africa via specific, identifiable corridors, including a route across the Bab el-Mandeb Strait connecting the Horn of Africa to the Arabian Peninsula, a body of water that, during certain periods of lower sea level connected to Ice Age climate cycles, would have been considerably narrower and more crossable than it is today. This detail matters enormously because it highlights something genuinely important running throughout this entire topic. ancient human migration wasn't purely a story of pure willpower and physical endurance, it was also a story of ancient humans taking direct advantage of favorable environmental conditions, narrower water crossings during specific climate periods, land bridges exposed during glacial maximums that simply aren't available under modern sea level and climate conditions. Now let's bring up the Bering Land Bridge specifically, because this represents one of the most genuinely significant geographic features in all of ancient human migration history. During the last glacial period, when enormous quantities of the planet's water became locked up in massive ice sheets, global sea levels dropped considerably, exposing a wide land connection between Siberia and Alaska, a region researchers now refer to as Beringia. This land bridge allowed ancient human populations to walk directly from Asia into the Americas, without requiring any boats or sophisticated water crossing technology at all, simply by following game animals and gradually expanding eastward across what was, at the time, perfectly ordinary, walkable land, rather than the open ocean separating these two continents today. This single geographic feature explains an enormous amount of how humans successfully populated an entire hemisphere that, under modern sea level conditions, would otherwise require genuinely sophisticated maritime technology to reach at all. Ancient humans weren't performing some kind of miraculous ocean crossing to reach the Americas. They were taking advantage of a temporary, climate-driven geographic shortcut that simply doesn't exist under current environmental conditions, walking across what's now a stretch of ocean separating two continents, because at that specific point in history, it wasn't ocean at all. Let's bring up something genuinely remarkable regarding Pacific Island colonization now, because this represents a completely different category of ancient travel challenge, one that absolutely did require sophisticated, deliberate maritime technology rather than simply walking across exposed land. Polynesian voyagers successfully colonized an enormous range of remote Pacific islands, separated from each other and from any mainland by genuinely vast stretches of open ocean, using double-hulled outrigger canoes capable of carrying entire founding populations, along with the plants, animals, and supplies necessary to actually establish a sustainable new settlement upon arrival. This wasn't accidental drifting. Archaeological and genetic evidence, along with the deliberate inclusion of breeding populations of specific plants and animals aboard these voyaging canoes, strongly indicates intentional, planned colonization voyages, undertaken by people who fully expected to find land and intended to establish a permanent settlement once they did. Now let's bring up the genuinely impressive navigation methods that made this kind of open ocean voyaging possible in the first place, because this represents one of the most sophisticated bodies of practical scientific knowledge developed anywhere in the ancient world. Polynesian navigators developed and refined a navigation system based on careful, detailed observation of star patterns, ocean swell direction and pattern, cloud formations, and even the specific flight patterns of certain seabird species known to nest on particular islands, all combined into an integrated mental navigation system passed down through intensive oral training and direct apprenticeship, allowing skilled navigators to successfully cross hundreds or even thousands of miles of open ocean without any written charts or modern navigation instruments whatsoever. This deserves genuine, considerable respect, because successfully navigating open ocean using purely observational, memorized techniques represents a level of accumulated practical scientific sophistication that's genuinely difficult to fully appreciate from a modern perspective, where satellite navigation has made this entire skill set essentially unnecessary. Polynesian navigators could reportedly detect the presence of an island they couldn't yet see directly, purely by observing subtle changes in ocean swell patterns caused by that island disrupting the surrounding wave patterns. A level of practiced environmental sensitivity that modern researchers studying traditional Polynesian navigation have found genuinely difficult to fully replicate even with considerable dedicated training. Let's bring up something genuinely important regarding boat technology more broadly, because Polynesian outrigger canoes represent just one specific regional example within a considerably broader, independently developed body of ancient watercraft technology. Different ancient cultures facing different specific water crossing challenges developed genuinely distinct boat designs suited to their particular environment and travel needs. Reed boats in certain ancient Mediterranean and South American contexts, Dugout canoes carved from single large tree trunks across numerous river and coastal cultures worldwide, and skin-covered frame boats in certain northern and Arctic regions, where wood was considerably less available than animal hide and bone for constructing a lightweight, durable watercraft frame. This variation reinforces something we've consistently found throughout this entire series. Ancient technology development wasn't some single, universal invention spreading outward from one specific origin point. It represented countless independently developed regional solutions, each one specifically optimized for the particular materials, water conditions, and travel requirements of that specific local environment. Now let's address something genuinely interesting connecting this entire topic to the deep prehistoric human migration into Australia specifically, because this represents one of the most genuinely impressive and frankly somewhat mysterious water crossing achievements in all of ancient human history. Even during periods of significantly lower sea level, reaching Australia from Southeast Asia required crossing a genuinely significant stretch of open water. Water deep and wide enough that it was never fully exposed as walkable land even during the most extreme glacial periods. This means ancient humans reached Australia, with evidence suggesting this happened at least 65,000 years ago using some form of deliberate watercraft, considerably earlier than the more famous Polynesian voyaging we just discussed, despite working with presumably less sophisticated boat technology than later Pacific voyagers eventually developed. This represents a genuinely fascinating, still actively debated mystery within archaeology. Exactly what kind of watercraft these early travelers used, and exactly how sophisticated their navigation and planning actually was, remains considerably less well understood compared to the more extensively documented Polynesian voyaging tradition. But the basic fact itself is genuinely undeniable. Ancient humans reached Australia by deliberately crossing open water tens of thousands of years before any other documented evidence of sophisticated ancient maritime travel anywhere else in the world, suggesting humans were experimenting with water crossing technology considerably earlier and considerably more successfully than popular historical narratives typically give them credit for. Let's bring up something genuinely important regarding pack animals and how they transformed ancient overland travel capacity, because walking, while genuinely impressive on its own, has obvious practical limits regarding how much supply and equipment a single person can realistically carry across long distances. Domesticated pack animals, horses, camels, donkeys, and in certain regions llamas, dramatically expanded both the speed and the carrying capacity of ancient overland travel, allowing groups to transport considerably more supplies, trade goods, and equipment across considerably longer distances than would have been practical relying purely on human muscle power alone. This technological development connects directly to something we discussed in a previous video regarding animal domestication, the same underlying domestication process that eventually gave us dogs and various livestock species also fundamentally reshaped how far and how efficiently ancient humans could actually travel once specific animal species had been successfully tamed and bred. For exactly this purpose. Now let's bring up something genuinely fascinating regarding camels specifically, because they deserve particular recognition for how dramatically they transformed travel and trade across some of the planet's most genuinely hostile, difficult to traverse terrain. Camels possess a remarkable suite of physiological adaptations, including the ability to go considerably longer without water than most other large mammals, and a genuine tolerance for the kind of extreme heat and difficult terrain found throughout major desert regions that made them genuinely indispensable for trade and travel across the Sahara, the Arabian Peninsula, and significant portions of Central Asia. The development of effective camel saddle technology specifically, allowing riders and cargo to be properly secured and balanced, represented a genuinely significant technological innovation in its own right, transforming camels from simply useful pack animals into genuinely efficient long-distance desert transportation, opening up trade routes across terrain that would have been brutally difficult, if not entirely impractical, to cross relying purely on human or horse-based travel alone. Let's bring up something genuinely important regarding trade networks specifically, because long-distance ancient travel wasn't purely about migration and resettlement. An enormous amount of ancient long-distance movement was specifically driven by trade, the deliberate, repeated movement of goods and materials across genuinely vast distances, connecting communities that never had any direct, permanent contact with each other, but still managed to exchange goods through a chain of intermediary trading relationships. Archaeological evidence regularly finds materials, particular types of stone, shell, or other distinctive raw materials, hundreds or even thousands of miles from their actual point of origin, demonstrating that extensive trade networks existed considerably earlier and covered considerably more ground than popular imagination typically assumes, connecting ancient communities into surprisingly extensive, interlinked economic systems long before anything resembling modern transportation technology existed. Now let's bring up something genuinely interesting regarding the psychological and social dimension of ancient long-distance travel, because successfully undertaking a genuinely difficult, multi-week or multi-month journey required more than just physical capability and practical environmental knowledge, it required real social organization and cooperation too. Long-distance travel, particularly into genuinely unfamiliar territory, almost certainly involved careful group planning, shared resource management, and coordinated decision-making among multiple individuals, the same kind of cooperative social structure we've discussed throughout this entire series as being central to so much of ancient human survival strategy. A successful long-distance migration wasn't simply a story of individual physical endurance. It represented a genuinely sophisticated collective achievement, requiring trust, coordination, and shared commitment among an entire traveling group. Let's bring up something genuinely important regarding how ancient humans handled the considerable uncertainty and risk involved in this kind of travel, too, because, much like several other topics we've covered throughout this entire series, it's worth being honest about the genuine danger involved rather than presenting ancient migration as some kind of smooth, low-risk undertaking. Long-distance travel into unfamiliar territory carried genuine risk of starvation, dehydration, exposure to unfamiliar diseases, conflict with unfamiliar populations already occupying a given territory, and simple, fatal misjudgment of available resources or environmental conditions along the route. The fact that ancient humans successfully colonized nearly every habitable continent on the planet doesn't mean every individual attempt succeeded. It almost certainly means a considerable number of migration attempts failed entirely, sometimes catastrophically, while the surviving successful migrations are the ones that left behind the archaeological and genetic evidence we're now able to study and piece together. Let's also bring up something genuinely interesting connecting this entire topic to seasonal timing specifically, because successful long-distance travel, particularly across challenging terrain or open water, almost certainly required careful attention to seasonal weather patterns and timing, rather than simply departing whenever the idea happened to occur to a given group. Polynesian voyaging in particular shows evidence of careful seasonal planning, taking advantage of specific, predictable wind and current patterns during particular times of year to maximize the chances of a successful voyage. Exactly the kind of detailed, accumulated environmental knowledge we discussed earlier as being absolutely essential to successful ancient travel more broadly. There's also a genuinely interesting angle worth bringing into this discussion involving river systems specifically, because rivers represented one of the most practically significant, frequently underappreciated travel corridors throughout ancient human history. Rivers provided a reliable, predictable water source for travelers, frequently offered considerably easier terrain to follow compared to dense forest or rugged mountain terrain immediately surrounding them, and once watercraft technology developed sufficiently, allowed travelers to cover considerably more distance with considerably less physical exertion than walking the equivalent distance overland. Major ancient river systems, the Nile, the Tigris and Euphrates, the Indus, and numerous others, didn't just support the agricultural civilizations we typically associate with them. They functioned as genuine highways, allowing people, goods, and ideas to move efficiently across considerable distances, connecting communities along their length into far more integrated regional networks than would have been practical relying purely on overland travel alone. Let's also bring up something genuinely fascinating regarding how ancient humans handled long-distance travel through genuinely extreme environments, because certain specific migrations required overcoming environmental challenges considerably more severe than simply covering a long distance across reasonably hospitable terrain. Populations that eventually settled in the Arctic and subarctic regions faced genuinely extreme cold, limited food availability during significant portions of the year, and travel conditions that would be lethal without exactly the right combination of clothing technology, shelter knowledge, and travel technique we discussed extensively in previous videos covering ancient shelter and clothing. The development of effective sled technology, frequently paired with domesticated dogs specifically bred and trained for pulling, represents a genuinely significant innovation specifically suited to this kind of extreme environment, allowing efficient travel and supply transport across terrain and conditions that would make standard walking or pack animal travel genuinely impractical or outright dangerous. It's also worth touching on something genuinely important regarding how ancient humans actually carried and managed water during long overland journeys through considerably more arid environments, because this represents a genuinely critical practical challenge that doesn't get nearly enough attention in casual discussions of ancient travel. Ancient travelers developed various water storage solutions, treated animal skins, specifically shaped gourds, and eventually ceramic vessels, specifically engineered to minimize water loss through evaporation during extended desert or dry region travel. Knowledge of specific reliable water source locations along established travel routes, sometimes passed down across many generations as essential, carefully memorized practical knowledge, frequently represented the genuine difference between a survivable, successful journey and a fatal one, reinforcing once again just how much accumulated environmental knowledge, rather than just raw physical endurance, underpinned successful ancient long-distance travel. Let's bring up something genuinely interesting regarding how genetic research has actually helped reconstruct these ancient migration patterns with considerably more precision than was possible using archaeological evidence alone, because this connects directly to methodology we've discussed in several previous videos throughout this entire series. Analyzing genetic markers and mutation patterns across modern populations worldwide has allowed researchers to trace approximate migration routes and timing with a level of detail that wouldn't be possible relying purely on physical archaeological remains, which, as we've discussed previously regarding several other topics, frequently fail to survive intact across the kind of enormous timescales involved in major ancient migration events. This genetic evidence has, in several specific documented cases, confirmed and refined migration timelines that earlier archaeological evidence alone had only been able to estimate considerably more roughly, representing another genuine example of multiple independent scientific disciplines converging to build an increasingly precise, increasingly confident picture of exactly how and when these major ancient population movements actually happened. Finally, it's worth touching on something genuinely worth appreciating regarding just how much accumulated practical knowledge had to be successfully passed down, generation after generation, in order for any of this long-distance travel and migration to actually succeed at the scale we've discussed throughout this entire video. None of this happened because of one single brilliant innovation discovered once and then immediately applied everywhere. It happened through countless individual instances of practical knowledge, which specific plants indicate nearby water, how to read approaching weather from cloud formation and wind shift, how to construct a watercraft capable of surviving open ocean swells, being carefully observed, tested, refined, and then successfully transmitted to the next generation, who then refined it further still. This represents one of the most genuinely impressive, if frequently underappreciated, aspects of ancient human achievement, an entire body of practical, hard-won scientific and navigational knowledge built collectively and incrementally across an enormous span of human history, entirely without the benefit of writing, formal institutions, or any of the modern knowledge preservation systems we currently take completely for granted. So how did ancient humans actually travel so far? Based on everything we've covered throughout this entire video, the honest, complete answer comes down to a genuinely impressive combination of factors working together across an enormous span of time. Slow, generational migration patterns following resources and gradually pushing outward into new territory, rather than single, heroic individual journeys. A human body genuinely well-suited for sustained, long-distance walking. An enormous accumulated body of practical environmental knowledge passed down through generations, allowing safe navigation of unfamiliar terrain. Strategic advantage taken from temporary climate-driven geographic features like exposed land bridges during glacial periods. Genuinely sophisticated, independently developed boat technology and navigation systems, allowing deliberate, planned colonization of even the most remote Pacific islands. The domestication of pack animals dramatically expanding overland travel capacity and speed, and extensive interconnected trade networks demonstrating that ancient communities were considerably more connected considerably earlier than popular historical imagination typically assumes. And honestly, maybe the most genuinely impressive thing to take away from this entire topic is recognizing just how much of our species' current global distribution traces back to nothing more sophisticated than patient, accumulated human ingenuity, generation after generation refining environmental knowledge, technology, and travel capability, slowly, steadily expanding the boundaries of where humans could actually survive and thrive. We didn't spread across nearly the entire planet because of any single brilliant invention or any single heroic journey. We did it the same way humans have accomplished nearly everything else we've covered throughout this entire series, through patient, accumulated knowledge, careful environmental observation, and the simple, persistent willingness to keep walking a little bit further or sailing a little bit further out into open water than the generation that came immediately before.